Let's see how do we find the square root of decimal numbers. Now this is very similar to the method of finding root by division method. So let's take an example in this case, and we start with the number 7.29, and we need to find the square root of this number. So what we do over here is, on the decimal front, if we take the number after the decimal, we start with the first digit after the decimal and we start pairing the number and placing a bar over them. And on the left side, on the integral side of the number, we again start from the units place and place the bars in the similar way as we do in the standard finding the root by division method. So now again, we take the 7 in this bar and we see that it is more than 2 square and less than 3 square. So we start with 2 here and we place 2 in the quotient area. We put a 4 over here, and after subtracting we get 3. And now since we need to get the number which is after the decimal, we place a decimal in the quotient area also, and we bring this 29 which is after the decimal along with this 3. So this number becomes 329. Now we get double of this quotient, which is 4, and we place a dash along here and a dash in the quotient area also. So now if we see, if we multiply 47 with 7, what do we get? We get 329. So, and we are left with no remainder over here. So 2.7 becomes the square root of 7.29. Let's take another example. We'll take a number which is 110.25. Let's find the square root of this number using the same approach. Now here again we start putting the bars. After the decimal, we start from the first digit, which is 2 in this case, and we place the bar over a pair of digits, which is 25. On the left side, on the integral part of the number, we start with the units place, which is 0 in this case. So we place the bar over a pair of digits, which is 1, 0, and the next is only a single digit, 1 left. Now we know that 1 square is 1, so we'll take a 1 over here. And now this is obviously 1 minus 1 is 0. So now we bring this pair, which is 10, under the next bar. We bring it down here and we bring double of the quotient here, which is 2, and place a dash over here. So now we know that even if we place a 1 over here, so 21 multiplied by 1 becomes more than 10 that we have over here. So we cannot place 1. Now we'll need to place a 0 there. So we put a 0 here and we put a 0 here, and now we bring this 25 after the decimal place here. Now since we are bringing the decimal part into this division, so we'll place a decimal in the quotient area also. So now we know we place another dash over here and in the quotient. So now we know that if we multiply 205 with 5, we get 1025, and there is no remainder. So clearly 10.5 is the square root of the given number, which was 110.25. Now we'll see how do we estimate the square roots and when do we actually do that. If the given number is not a perfect square and we need to find out an estimate as to what will be the range in which its square root will lie, that is where we use this approach. Now based on the number of digits, we'll first estimate how many digits will its square root have. Say for example, if we have a 4-digit number, we know that its square root will be a 2-digit number. It cannot be a 3-digit number. Because if we see that if we take the smallest 3-digit number, which is 100, its square itself becomes a 5-digit number, because it's 3-digit number 100 and it becomes 10,000, which is a 5-digit number. So if we know that if we have a 4-digit number, its square will be a 2-digit number. So that is how we start with finding the how many digits should we start with. We take any two perfect squares between which the given number lies. Now let's understand that with the help of an example. Say for example, we take a number which is 200. Now if we just look at it, we know that this will have a 2-digit square root. Now if we know that, and we know that if we take 10 as the number, then its square is 100, and if we take 20, its square is 400. So we know that the square root of 200 will lie somewhere between 10 and 20. Now this is a very big range to have. So we now narrow down these two perfect squares and then estimate the perfect square of to the nearest natural number. Now we start narrowing it down and we see that the square of 14 is 196 and the square of 15 is 225. So we know that square root of 200 will lie somewhere between 14 to 15. So that is the estimate that the square root of 200 will lie between 14 and 15. Now we were just doing the estimation for the square roots when the number is not a perfect square, but we can actually find the square root. Instead of just estimating, we can actually find out the square root of a non-perfect square also. We can take it up to 2 to 3 decimal places. So how do we do that? We find the square root up to 2 to 3 decimal places by adding zeros after placing a decimal and zeros to the main number to which we need to find the square root of. So let's take an example of 2. We want to find out the square root of this. So how do we start with this? We take the number and obviously place the bar. So this is the single digit. So we place the bar over 2. So 1 square is clearly less than 2, and we cannot take 2 square, which will become more than that. So we subtract, we get 1. Now since there is no other digit in the original number, we place a decimal and we add 2 zeros. We'll always place even number of zeros, always place 2 zeros in one go, and we'll bring them down and place the decimal in the quotient area also. Now we bring double of it here, and we need to place a digit both in this area and the quotient area, so that this product is less than 100. So we know that 24 multiplied by 4 is 96. So we bring that down, and on subtracting we get a 4 over here. Now we place 2 more zeros here and we bring them down, and now we take the double of this, which is 28, and we put a dash both in both the areas. Now we know that 280, if we take 282 multiplied by 2 will become more than 400. So we take 1 over here. 281 multiplied by 1 is 281, which we place over here. And on subtracting we get 119. And we again place 2 zeros over here, which we can show placed here also. Now if we again take double of this, which is 282, and a dash over here. So if we see, it again gets multiplied with 4 and it becomes, which is this. And here again we get some remainder, but we may leave at 3 decimal places. We can leave at 2 or 3 decimal places depending upon what is required. So this is how we'll find the square root of non-perfect square by adding zeros after the decimals, and we'll continue with the same division method to find the square root. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.